All right, number 14 asks us to find the radius of a circle given a linear speed of 32 meters per second and a rate of rotation of 100 revolutions per minute. So the equation that we're going to need to use to find the radius is this one. S is equal to r theta, where S is the arc length. So if we think about our circle here, we've got our radius here. The arc length is this piece of the circle that's intersected by this angle. And the angle is theta. So S is the arc length, the angle is theta. And if we know those two things, then we're going to be able to figure out the radius. Now in this case, we're not talking about just a piece of a circle here. We're talking about going around the circle many, many times. Because this circle is traveling at a rate of 32 meters per second, and it's spinning around 100 revolutions every minute. All right, so let's use this linear speed to figure out the arc length. We'll use the revolutions per minute to find the angle, and then from there we'll be able to find the radius of this circle. All right, so to find the arc length given this linear speed, we first have to think about, well, the equation for linear speed is v is equal to s divided by t. And what's the t here? Well, the t is for time. And here notice that our linear speed is in meters per second. Our rate of revolution is in revolutions per minute. So let's get both of these in terms of 1 minute. So let's make that time 60. So there's 60 seconds in a minute. So if we divide our arc length by 60 seconds, then that's going to give us this velocity, or this linear speed of 32 meters per second. And so now we just need to multiply both sides by 60, and so we get S is equal to 32 times 60, which is 1,960 meters. So in other words, that's how far, if we're going 32 meters per second, that's how far we've gone in a minute, is 1,960 meters, which is pretty fast, because a mile is about 1,600 meters. So we've gone more than a mile in 1 minute. So we're going well over 60 miles an hour here. But the important thing here is our arc length is going to be 1,960. If we've traveled that far, imagine taking that 1,960 meters and wrapping it around a circle a bunch of times. That's going to be our arc length. All right, the angle now, we're going to use this revolutions per minute. So since we're just looking at 1 minute, that's what we got this into, that we're going 1,960 meters in 1 minute. So we're going 100 revolutions. We don't have to worry about the per minute. We're just considering what's happening in 1 minute. So we're going 100 revolutions. So our angle is going to be equal to 100 revolutions multiplied by, remember that all the way around a circle is 2 pi radians. So we're going to take that 100 revolutions times 2 pi radians per revolution. And that gives us an angle of 200 pi. So our angle is 200 pi, our arc length is 1,960 meters, and now we have all the information that we need to plug into this formula and find our radius. So the arc length, S, is 1,960, and that's equal to the radius times the angle, which is 200 pi. And now to get r by itself, we divide both sides by 200 pi. We get that the radius is equal to 1,960 meters divided by 200 pi radians. And if we plug that into the calculator, we'll get that that's approximately equal to 3.12 meters. That's going to be our radius, is 3.12 meters, which is big. That's over 10 feet, which means the diameter of our wheel is over 20 feet. But that should make sense because 100 revolutions really isn't that fast. It's just a revolution and a half every second. Whereas the speed we're traveling at highway speed while only going 100 revolutions per minute. This is going to have to be a big wheel to accomplish that. But the radius would be 3.12 meters.